In this section, you learn about options to implement topic modeling. You can use Amazon Comprehend to examine a collection of documents to determine common topics. For best results, you need to use at least 1,000 documents in each topic modeling job. With Amazon Comprehend, you do not need to train a model or pre-process your data. To get started, create one or more UTF text files in an Amazon Simple Storage service known as Amazon S3. Then, create an Amazon Comprehend topic modeling job. When a job is complete, you have two output files. The first, topicterms.csv, contains a list of all the topics and the top terms for each topic according to their weights. The weight represents a probability distribution over the words in a given topic. Amazon Comprehend only returns the top 10 words for each topic. This means the weights won't add up to 1 unless you have fewer than 10 terms. The 10 terms should be enough for you to determine whether a topic makes sense. Amazon Comprehend can detect up to 100 topics per job, but you can specify how many you want to find based on your domain knowledge. The second file is the doctopics.csv file. This lists the documents associated with the topic and the proportion of the document that is concerned with the topic. Note that the names of the topics are not given. Naming the topics is a human task. Amazon SageMaker contains two built-in algorithms to extract topics from text. The first is Latent Directlet Allocation, or LDA. LDA is an unsupervised learning algorithm that attempts to describe a set of documents as a mixture of distinct topics. Because this algorithm is unsupervised, the topics are not specified up front. The topics might not line up with how a human would categorize documents. The topics themselves are learned as a probability distribution over the words that occur in each document. Each document, in turn, is described as a mixture of topics. As an example, consider a set of documents that only contain the words eat, sleep, play, meow, and bark. LDA might produce the two topics shown in the table. Topic 1 might be about cats, who are likely to meow and sleep. And topic 2 might be about dogs, who play and bark. To train an LDA model, you need a set of documents. Pre-process these documents appropriately, depending on your documents. The typical steps you would take are to clean the text, remove stop words, remove non-text, and perform lemmatization. Next, tokenize the text by using a bag of words, or BOW, or some other tokenizer. Note that lemmatization significantly increases algorithm performance and accuracy. To train, you need to supply the data on the train channel. You can optionally supply test data, which the final model scores to provide the metric test PWLL. PWLL is the per-word log likelihood on the test dataset. This metric represents the likelihood that the learned LDA model accurately describes the test dataset. The goal is to maximize this value. The data can be in a record IO wrapped protobuf or .csv file. You must supply a few hyperparameters. The first is num topics, which is the number of topics for LDA to find within the data. The second is feature dim. This is the size of the vocabulary of the input document corpus. The final hyperparameter is mini batch size, which is the total number of documents in the input document corpus. LDA only supports single CPU training. The output of the training job is a model that can identify topics that are discovered from the input corpus. To infer from the model, you must deploy the model. Once deployed, you should run your documents to infer through the same pre-processing pipeline before calling the model. The output of the model is a Python dictionary that contains predictions with each topic mixture referring to an input document. Each element of the topic mixture corresponds to a topic learned when the original model was trained. In the example shown, the first document is most likely about topics 2 and 5. The second document is likely about topics 2 and possibly 4, depending on your threshold. Thanks for watching. In the next video, you'll learn about the Neural Topic Model, or NTM algorithm.